Hello, welcome to my demo. In this demo, I'm going to showcase how we can develop LLM question answer applications on top of the SageMaker. In this demo, we are going to collect the data from various sources like S3, Amazon RDS, or Redshift, Snowflake, or any kind of data sources. We can combine all these data sources using the Glue data catalogs. Even if there is a third-party API, we can collect those data into uh, Glue data catalogs, or we can directly get answers of users' questions from that API. So the basic architecture is like if you have some clients or user, they want to get any kind of data, or they want to get any kind of analytics or any kind of answers from various data sources. They can just write like normal human questions like what is the average price of particular airlines, or what is the delay in the flight when flight is flying from Delhi to Mumbai. So such kind of any kind of questions when user want to ask, and if you have multiple sources. So in this case, how we can combine these multiple sources and we can generate very human readable answer using the RAG framework with Langchain. So Langchain is we can say that it is a generative AI framework, and here in this use case we are going to use OpenAI API. But instead of that, we can also go with any other open source models like Hugging Face or Filecan or any kind of open source model, and we can develop the same use case with other open source applications, other open source models as well. So very first step is that user will ask any kind of questions, and that questions will be formatted as a prompt, and it will come to my studio notebook, and I will go to all these data sources, and I will find out that which data source is the best to generate this answer. So let's take example, I have some S3 data, and S3 is the best for to generate this answer. I will forward it to LLM. So basically like if in this case OpenAI, in another case it can be Hugging Face or any model, that model will generate the data. So and like what are the particular answers, if you are asking like what is the mean price of SpiceJet airline, so it will do all kind of calculations, and it will give the particular answer. Now this particular again the RAG framework. So RAG, it will do a retrieval augmentation generation. So it will generate all these answers in very human readable format, and what are the data it has gone through it, you can store that the particular databases, that like this was the particular results I found from different sources, and that particular answers you can going back and pass to the user. So this is the architecture, and now to implement these architectures, I will showcase you how we can develop this in the SageMaker. So this is SageMaker. Here we can have this dashboard, and in this use case we are only going to use a notebook instance from the SageMaker. I have already configured one notebook instance, that is LLM demo, and by clicking here open Jupyter Lab, it will open into the new tab. So this is my notebook. The first step is that I have to do some installations like requirement.txt. So this is the SQL Alchemy Snowflake. If you are connecting with Snowflake or Redshift, so you can install these particular packages it would require. Second thing is that uh, you have to set up the system variable, environment variable for OpenAI API key or any other environment variable if you have. So you can just load.env and load dot environment variables. Then we are using a Python and JSON, SQL Alchemy, then Langchain frameworks, different models from Langchains. Just let me run it. So we have imported all the libraries. The next step is that in this demo I'm going to create a new database. So let's take example, there is a flight DB3, and my new role will be glue role. So this is basically we are going to create one glue role. I can give like today's date, it will create a new glue role, and this is a glue crawler. So what we are doing, if you see this particular diagram, so we have S3 bucket. On S3 bucket we are running the glue crawler, and it will generate the glue data catalogs or glue tables. So basically, what is a glue? So glue is like one kind of utility. We can say that if you have some data in S3 uh, and CSV format or JSON format, and you want to make it queryable, like if you want to query over the data in the CSV, you cannot do directly, right? Either you can go with the Python pandas and then you can write some kind of query. So instead of that, using the glue crawler, you can create one crawler and that crawler will run. So let me show you. This is like already generated crawler. So this is a yeah, you can define like which database it should be stored, what are the outputs. You can see like data sources. So this is S3 demo and flight is my bucket. So let me show you this particular bucket. So this is the bucket and there is a data inside the flight. So flight price.csv, this is my data. When I will run the crawler on top of this, so it will generate one database. So like already I have one db2, so same it will generate some another database in this use case, and inside that there will be table. So table name is a flight. You can see the location. So this is particularly pointing to my S3 location only. It is not copying any data. It is just creating a schema on top of that, so you can make it queryable. So this is my all the columns inside this my data sources like airline, flight, source, city. Now if you want to access this data, so what you can do, you can just directly go to the Athena and you can select a particular database and table. So flight db and flight is my table. I can just query over this, run a query, and it will give me the answer like the SpiceJet flight is running from Delhi to Mumbai and economy class and all these informations. So basically we are going to use this table and our user will ask any kind of questions on top of this, like they might be asked like how many flights are flying from Delhi to Mumbai for particular airline like SpiceJet, or how many flight are flying from Mumbai to New Delhi and timing is evening, right? So such kind of questions like user can ask and we can get answer on that. So coming back to our module, our LLM demo. So we are just defining that we want a new database DB3. We want a new crawler. So that is a crawler version 3, and this is service role. So all this is going to be generated automatically. So first we are creating AWS policies. Okay, so blue data bucket name is not defined. Okay, okay, yeah. Panda chat. Okay, so here the issue. Yeah, I know it. I'm not record this Panda JI, so I'm just removing it. Yep. Then blue bucket. So this is giving my account. Then create a blue service and role policy. So this is like common steps which we particularly doing with AWS. Then create a database. So by running this, I'm going to create a new database, and my database is flight db3. So successfully created flight db3. We can go to the blue and verify. Yep. So database is just to refresh it here. Yep. So this new database is created, and right now there is no table inside that. Okay. So going back, create a glue crawler. So this is my bucket name. Inside the bucket there is a flight folder. I want to create a crawler on top of that. So it is going to create a crawler, and it is saying that successfully created crawler. Okay, like let's go to the again glue and we can verify the crawler is there or not. So previously it was version 2, now we have version 3 crawler as well, and this is just in the ready state, and it didn't run any time. We can see the data source is the same like flight, and we can select the classifier. There is no classifier, tags, no tags, just we didn't pass it from our code. Okay, and this is the role that I just created. Now crawler is ready and we can start running the crawler. So it will take some time, like might be take 2 to 3 minutes. So what it will do that first it will spin up this crawler, and it will generate it will go to my particular table. It will start to understanding that particular table, create a schema out of them. So you can see that it started, and right now status is running. Let's wait for some time. Once the crawler is run, we will get one table instance. That table is created, and then we can check the table from the database table. You can also query it from the Athena. And here we are also getting like statuses, like it is running. So once the running is done, again it will be stopping, and then it is going to be ready state. Once that status is ready, that means our table is created and we can go ahead. So still it is running. Yep, it is showing that now it is completed and one table changes. So it is saying that one table is generated. We can go to the database. This is my flight db3 new database. Inside that there will be a table. Yep, so this is a flight table. Now I just go to inside this table and I can see that my all the schema is available. For verifying that schema and all this, I can just go to Athena. Athena is like a querying tool. I can just select the flight db3. Here my table is the flight. I can just change it and run it. So here you can see that it is getting all this output, same as like the previous one. Okay, so right now status is stopping. Once this status is done, once the status is ready, we can go ahead and run the next cell. So in the next step, like what we are doing, so if we go to this diagram and we can connect, so this step is done. Now we have to connect this glue and our LLM notebooks or LLM code. So to fetch particular records or to fetch particular answers from your data sources, you have to collect these glue data catalogs with RAG framework. Okay, so now this is stopped. Okay, so we can go ahead. So first we are generating the client, then we are just basically we are doing this connection string only. Okay, so if you have any kind of experience in past like Java or Python, you might be aware that to connect with any kind of application like UI and backend, we require this connection string. So if we want to just print it to verify, so I will just print it like this. So this is a connection string, Athena test, and here my database. It is saying that this is a location of database. So this is my connection string, and I'm getting all the data bases from this particular connection string. So I have this database flight db3 from this connection string to utilize further. Next step is generate dynamic prompt template. So what is a prompt? So when we are asking a question to ChatGPT, if it is some kind of intuitive, okay, then ChatGPT will give you more better answers rather than giving like any kind of vague answer. Okay, so when you're asking a question, you should describe it properly in which format you require. Like I want this in particular 20 words or 20 characters, or I want to ask it as like interview question answers, right? So that in that case, like it will give you good answers. Okay, so for that we are uh, generating some templates. So first I'm just checking that glue data catalogs, what are the things inside my glue data catalogs, and let me just run it first. Okay, so the output is like that. We are checking like this is my database, this is the table name and source city, departure time. So we are particularly together, we are combining all this our data catalogs. Okay, so we can say that this if your client will ask any kind of questions like how many stops are there when you are flying from Delhi to Mumbai, so we can go to that catalog and we can find out that yeah, this stops keywords is there, right? So such kind of things is for finding out the answers. So basically what we are doing that we are creating a Boto3 glue client. Then we are traversing through all the tables inside my tables list. Here I have only one table. Then we are checking that what is its data source. So data source is S3 just because the original data source was S3. Then we are checking the table name and column name and combining all these things, and we are just printing it to create one glue data catalogs, and we are storing that inside the glue data catalog variable. Now defining the LLM. So here I am using the OpenAI key, but you can use any other key as well. Like if you want to go with the Falcon or Hugging Face models, okay, like Bloom or Dolly, you can also use it here. To be aware that like OpenAI key, you should require organization ID and you should have a paid account, so you will get the OpenAI key to run it. So I already set this key in the backend. I'm just defining the LLM variables. Okay, so what it is, the issue, pip install OpenAI, please install it. Okay, okay, let me edit here only. Okay, define LLM. Yep, so it is defined now, the LLM variable. And if you want to see like what is inside this LLM, so it has like all the purpose and all the metadata information about the LLM model. Now define the functions to determine. Okay, so here we are determining first thing is like which database we have to use, the best data channels to answer the query and generate the response to the query. Okay, so identify the channel. So channel, here we are using only the blue data catalog, and this is a prompt of prompt templates. So when it is going to be asked to OpenAI, what it will ask like from the table below, find the database. So I have only one database in column database, which will contain the data in the corresponding column name. And so this is like blue data catalog that we generated in the previous step. Give your answer as a database, so it will give answer back it like this, and give your answer as database dot table, so it will also print which database and which table is there. Then we are passing to the prompt template, so the above template and input queries, so like what are the queries written from the UI, from the user. Then passing to the LLM chain. So LLM chain, when you have uh, to chain multiple answers, okay, so you can use the LLM chain. So it will do some such, it will not give the straightforward answer, so it will particularly check and define the different channels, chain on top of the answers. Then LLM chain dot run, so you are passing your ultimate query and it will give the generated text. So whatever the generated text it is getting back. And here we are also checking that if generated text has the S3. So uh, here we will have the S3 just because our data is in S3. So we are setting the channel is equal to database and database equal to Athena and set database to Athena. Okay. And next function is run query. So this is actually run query that will be called from the client. And from this we are calling the identify channel. So here we will have channel and DB, two things in back. And this is a default template. So given the input question, first create syntactically correct, then we are passing the dialect to the template and query to run, and do not append a query to SQL query. So this is like some default template we are passing, and the question is like input. What are the inputs is coming from the user and end user, that will coming as the questions. Then prompt template. So prompt SQL prompt template we are defining with the input variables, so input table name and dialect. And then the above default template we are passing to this prompt template. Then we are checking whether channel is equal to database or channel is equal to API if we are some kind of third-party API. So in our case, it will be a database only. So it will pass from SQL database chain from LLM, and we will have a DB chain in the response. Then we are passing the DB chain to the run query, and here we will get our ultimate response from the OpenAI. Let me run this first. Next step is like, so this is our actual ultimately user will ask a question like uh, what is the mean price of flight SpiceJet. Okay, so how many number of SpiceJet flight are there? I want mean price. Okay, so just running this query and it will give me the mean price of SpiceJet. If you see here like which database, which table name, set database to Athena. So step completed, channel is database, and this is like a query that what we can write into the SQL kind of query. So average price from flight where this is airline is equal to this, and this is my answer. The mean price of flight SpiceJet is 6179.28. Okay, so this is like very we can say that great answers, and same it like human readable format. Okay, and let me ask one another questions like how many flights, how many flights are running between Delhi and Mumbai. So it is going to be like generate the first SQL query. So select count from flight where source is equal to Delhi and destination is equal to Mumbai, and it is saying that yeah 51,000 flights are from Delhi to Mumbai. Okay, so this is like a great answers, and like it is generated that using the RAG framework, right? How we can give proper answers to client. Now if you want to verify my first questions, okay, so I have the data sets, okay, already loaded, and if you want to verify like what is the mean price of SpiceJet, so you can see that previously it was answered like 6179, and here I will also get the same answer. So this is like my data, and this is like a 6179, uh, the total mean price of SpiceJet. Okay, like same like if you want to check like departure city and destination city like Delhi to source city and destination Delhi to Mumbai, though it will also give the same answers to verify this. Yep, that's all, and thank you for watching this demo. uh, Let me know if you have any kind of questions, and make sure that once you are run this, clean up all this like if you are running this crawler, if you are running these notebook instances, just make sure that you delete to save from the costing. Yep, thank you.